Generally, structural systems with complex forms and geometries are applied to very prestigious works of architecture and realized with sophisticated technologies, as we have seen right now, until now. The design process that I will present here today is actually investigates the possibilities of building geometrically complex architecture using simple techniques, as Jona Friedman and Eva Schauer in this building museum in Madras, and cheap materials, as in this chapel in Alabama rural studio, and achieving yet a meaningful structural and architectural performance. Within an experimental workshop run by me and my colleague Stefan Pollak, a team of 5 students and the 2 of us built a real-scale artifact, a temporary multi-religious pavilion with a tensile roof made of cardboard, recycled cardboard. The geometry, an undulated hanging comb carpet, as I will show later, emerged from a collective design and a form-finding process, where a diagrammatic and multiscalar approach was applied both in digital and physical explorations. The attempt of this research was to relate, even in conditions of scarcity, formal complexity to a productive loop of digital, manual and physical interactions, considering the architectural project as its creative synthesis. The structure indeed was a good opportunity to investigate both morphogenesis and production, because on one hand it was small enough to be built from this small group from conception to completion, and to introduce non-conventional technological solutions, but it was also real enough to trigger operative thinking on economical, productive, and programmatic issues. I will now start from the end, just telling you a bit about this, what we call the ritual of building, and giving you some dimensional data and construction data. We use approximately 4,000 triangle sheets cut from recycled cardboard boxes collected from supermarket, and some 8,000 joints closed with blind rivets. What is probably the most astonishing thing is that with less than 1 meter cube of material, we could develop more than 50 meter cube of construction material that we pre-assembled and stored, and finally we realized more than 30 meter squares of cover area. As you can see, this production was rather labor intensive, which is apparently an efficient working method for an industrialized society. But manual action gives the advantage to establish a straight, direct connection with the laws of physics and mechanics. And the manual selection within an amount of discarded materials is also a crucial factor on turning waste into resource, while shaping useful and possibly beautiful objects. Let me now introduce the way we run this experiment, and the way we try to look constantly at the relationship between structural behavior and spatial quality. As a result of a diagrammatic and collective design. In order to get familiar with the tension between control and freedom, in the first experiment on mosaic patterns, we use an intuitive approach. We explore construction principles and structural constraints through a manipulation of a specific material within a system of very simple rules, and not triggered by intentions, but rather activated the intrinsic creativity of an abstract material before assigning scale and function. This approach anticipated the diagrammatic and multiscalar method. Similar results indeed can be obtained with digital diagrams, which have the capacity of gathering virtual information while making formal structure materialize. And actually the design outputs have been generated by a mapping procedure. At a large scale, choosing dynamics as ventilation flows, visual connections and shading patterns, and extrapolated from the context in a way that we could inform the initial strategic decisions. In an intermediate scale, The same approach was applied for an investigation on ergonomic conditions, referred to a series of ritual moments. The idea is to try to find a way of representing in an abstract yet operative way the differences between different beliefs and belongings, and to represent trying to find a common language. And the diagram do that by converting qualitative state into quantitative variables. Here an example of how the team agreed topological field, the elliptical shape, and the system of vector that virtually represents the individual ritual moments. And here you have just a small selection of that investigation. The diameters correspond to different ergonomic positions, like standing, being seated or lying, while the arrow shows a different direction. From this first generation of 2D diagrams, through a geometrical manipulation, the second generation of 3D surface was produced, with the idea of progressively acquire formal and programmatic issues. And finally, these geometric entities was merged through a process of morphing into a single surface that potentially and virtually incorporates traces of each finding. At this point, the integration of physical and digital models steered the trial and errors procedure where selective and collaborative dynamics, rather than an architectural gesture, made possible the emergence of the structural forms.